To solving lesson 10 part 2, multiplication property of inequality, case 2, negative factors. Consider 2 is greater than negative 3. If I multiply both sides by a negative 4, I would get negative 8 is greater than 12. Now that is obviously false. So it actually would end up being the other way to make it true. And that is going to be the thing we're going to have to remember. Anytime we multiply by a negative, we're going to have to switch the direction of the sign. There is another video that describes why that is. It's because it ends up flipping the number line. When you flip the number line, left becomes right and right becomes left. So you do have to switch the direction of the inequality sign. So when you multiply or divide by a negative, you need to switch the direction of the inequality sign. It will have to go the other direction. So when we solve these, negative 3 halves n is less than or equal to 6. I'm going to copy this down first. I'm going to multiply both sides by the reciprocal, negative 2/3. Now, when I multiply by a negative, I need to immediately change the sign. Okay, because I have multiplied by a negative, that sign needs to change immediately. Now, right here, I get 1n greater than or equal to 6 times negative 2/3 is negative 12/3. That's negative 4. Now, I can go ahead and graph it. My number line needs to have a negative 4 on it. And we'll throw some more numbers on just to make it nice and full. And our boundary is a closed boundary, so it's going to be a filled in at negative 4. And n is greater than, so we need to go towards the larger numbers. Now, when dealing with multiplying or dividing by negatives, it's even more important to check your solution. A solution. I'm going to check the solution 0. That's an easy number to plug in. Negative 3 halves times 0 is less than 6. 0 is less than 6 is true. Remember, I'm just plugging it back into the original inequality, and that solution is verified. Solve the inequality, graph the solution. Right here, we need to multiply both sides by negative 3. And when we multiply by a negative, we need to immediately switch the sign in that step. Don't wait till the next step to do it. This reduces to 1x less than. Negative 4 times negative 3 is positive 12. X is less than 12. So on our number line, we have to have 12. Okay. It is an open boundary, so it's not included. And x is less. Since x is less, we need the arrows to show numbers that are less. And then we need to pick the solution and check it. So let's try, well, something that'll be easy to divide by 3. How about we do 9? So 9 divided by negative 3 is greater than negative 4. That's just the original problem with 9 plugged in for x. So is negative 3 greater than negative 4? Well, that is true. So that solution is verified. 0.5 is less than or equal to negative y divided by 2. We need to multiply both sides by negative 2. Remember, when you multiply by a negative, you need to immediately switch the sign. Negative 2 times 0.5 is negative 1. And we get y on the other side. I'm going to reverse that so that the y comes first. It's just a little bit better if you do. So I need to make sure negative 1 is on my number line. It is going to be a closed boundary, so it's filled in. And y is less, so I need to go towards the less than numbers. And now I'm going to check a solution. Something easy to divide by 2. How about negative 2? Okay, 0.5 is less than or equal to y, negative y over 2. And that's going to be a negative 2 we're plugging in. 2 divided by 2 is 1. 0.5 is less than 1. That is true. So we did get that in the correct direction. Okay, solve negative 3z greater than negative 4.5 and graph the solution. I'm going to rewrite it so that it's not right in the middle of the sentence. I need to divide both sides by negative 3, and whenever you divide by a negative, you need to immediately switch the sign. Right here, these divide and we get 1. 1z is less than negative 4 divided by 3 is 4/3. So z is less than 4/3. I'm going to count by thirds. And 4/3 would be right here. So we have an open boundary at 4/3. And z is less, so we need to draw the arrow towards the less than numbers. And that's it. We'll skip verifying on this one. Solve the inequality, graph the solution. All right, here I'm going to divide by negative 5, and every time you divide by a negative, you immediately switch the sign. We get z is greater than negative 7. And the graph of it, we've got our negative 7. And it is not included, so open boundary, and z is greater, so it needs to go towards the larger numbers. Next one, negative 2a greater than negative 9. We're going to divide by negative 2, and anytime we divide by a negative, we need to immediately switch the sign. This gives us a is less than 4.5. And then the graph of this, here's 4, here's 5, and 6. Let's throw 3 on there. 4.5, open boundary, and a is less, so we need to have our arrow go towards the less than numbers.